All right. So I think you guys should be able to see my first slide. Thank you all for joining. I'm thrilled that you guys are here. If someone can put in the question section that they can actually hear me and see my screen, that would be perfect. Okay, awesome. Thank you, Marvin. Thanks, Susan. Perfect. Perfect, perfect. Okay. Oh, Rebecca says I have an echo. Does anyone else have an echo? Okay, no echo from other people. Okay. Well, Rebecca, maybe it has something to do with your speakers and the sound coming out of your speaker and out of your laptop. I'm not a techie person, so so maybe I'm not the right person to suggest how to fix that echo. All right, so we're just going to go ahead and get started. Welcome, everyone. I'm so glad that you wanted to come join me this Thursday evening. Hopefully you have a cup of tea and you're ready to go. Listen for about an hour and a half. There are quite a few slides, so let's get started. So this is a live class. I don't know if you guys have ever used GoToWebinar before, but for anyone who's not used it, you know, there's this thing right here and there's questions. So if you have a question throughout the seminar, please feel free to pop it in there. And I do have a couple poll questions. And so while you guys are answering your poll questions, I can read through the questions. There are a few handouts that Robin put on there for you guys. And so you're welcome to pull those up and download them on your computer if you are interested. And then at the end, I will try to unmute you, and then you need to go in and unmute yourselves, and then we can talk if you have questions. Now, when I did this last fall, I did not do it correctly, and I heard no one, and apparently someone had asked a question, and I never heard it. So, we'll just hope that this time I can listen to you guys ask questions. So I think that's all you need to know about GoToWebinar. So our objectives today are just to understand your roles and the importance you play as a weather spotter for the Weather Service. Talk about timely and accurate reports. Describe our cold season weather threats and the impacts we could see. How to play it safe during hazardous weather. And I will do a quick little outlook for this upcoming winter. So first, let's look back at what happened last year across our area. This happened right about 1 year ago. October 23rd and 24th, we had an early season snowfall with some reports, you know, quite high. Spokane had almost 7 inches, but Colville had 7 inches as well, as Malo had 8. And even as far down in Whitman County as Palouse had 2 inches. So it was quite an impactful thing. That picture is from the morning commute on the 24th, I believe. So quite an impact for our region, especially early season snowfall, freezing road temperatures, icy, slicky, snowy conditions on the roads, which made for a very long commute for some people that morning. We also had blowing dust a couple weeks later, November 7th, where visibilities were reduced to 1 to 2 miles across parts of the Columbia Basin, mainly Moses Lake, Ephrata, Warden, Soap Lake, and George. But, you know, for dust for us, I mean, a prime area that we see it is just east of Moses Lake to about Ritzville, and then south on 195 towards the Tri-Cities. That's like prime blowing dust area across our region. And on November 7th last year, that area did see it as well. Then as we moved into December, we did have a wind and snow event. So we had some good snow up towards the Cascades in Okanagan County. Mazama, Twisp, Concanoli had some good snow. And then we had wind down towards the Palouse. So this was a Pullman morning. They had some trees blow down, take some power lines down across the Palouse. And then we had our big January wind event, which also had some snow. Like Spokane didn't have snow, but other areas thereafter did. So like Lucerne, Leavenworth, Boyd's, mainly our mountainous areas, the Cascades, and then up into, Stevens and Pend Oreille counties. They had snow while it rained here and saturated the soils. And then the winds came and, anything that didn't have deep roots with saturated soils, the trees blew down. So that's a picture, a part of Comstock Park in Spokane with all the trees that were lost. I think there were something like 100 trees lost. It was a lot, but it wasn't just Spokane. I worked that day and across the valley, across into Coeur d'Alene, Post Falls, Airway Heights had problems. Just lots of areas saw winds, and the strongest winds with that system occurred early in the morning. It was 5, 6, up till about 7 o'clock in the morning were the strongest winds with this event. Then we had the March 28th, 29th blowing dust. We advertised this pretty big ahead of time. So we had visibilities reduced to 1 to 2 miles across, again, a lot of the Columbia Basin, and then up into Airway Heights as well. So if you're new and this is your first spotter talk, welcome. We are glad that you are here. This is for people who are just weather enthusiasts and enjoy, calling or submitting spotter reports, and you're okay with us potentially calling you to get real-time reports as well if necessary. So this is just you volunteer on an as needed basis or when you are available. Obviously, if you're on vacation, we don't expect you to call. You don't need any weather equipment. We just need you to be able to go out and look and give us reports. And we'll talk about different ways that you can submit your reports. But you basically become the eyes and ears of the Weather Service for us. So here's a picture of our operations area. And the Weather Service is part of the federal government. We are under the Department of Commerce. And then under that, we are under NOAA, which is the National Oceanic and Atmospheric Administration. And then the Weather Service falls under that. So we are responsible for all weather and water watches and warnings. So if you watch TV at night, like for example, if you watched TV tonight, you probably saw that there were some flood watches out. You probably saw that there's a wind advisory out till 11 o'clock tonight. Those were issued by our office, but it's the TV and media people that really sometimes help get the word out to a lot of people for us. There are 126 offices across the country, and we work with lots of local agencies. We are often kind of the behind the scenes. I think probably most people get their weather information from TV or their phones. Your phone is not set up for a weather service data. It's probably set to the Weather Channel or AccuWeather, etc. So, and we provide decision support for big events, concerts, sporting events, etc. And we do a lot of preparedness and education outreach across Eastern Washington and North Idaho. So this is a picture of the outside of our office. We do have 24 employees. That includes meteorologists, technicians, hydrologists, and then administrative staff. We are open 24/7 because weather happens 24/7. We do things like observations, so we release a balloon twice a day. We do forecasts out to 7 days. We do all the watches and warnings that you see that are issued across our region. So here's some of this is how the offices are broke up across the United States. And then on the right, you can see, this isn't a county map, although it kind of looks similar to some counties. This is how our forecasts are broken up. We call them forecast zones. And so they're kind of picked according to similar climates. So, if you click on our map on the front page, you might click on Spokane and it'll pull up that specific area, and that kind of ties into this zone as well. So we have 13 counties in eastern Washington, 8 in North Idaho, and the topography ranges is quite extreme from a couple hundred feet mean sea level pressure to 9,500 feet. So we've got a lot of topography, which adds to the challenge of forecasting in our region. So there are lots of tools and observations that we use, and I'm going to talk about a few of them here. First one is our radar. So if you were to ever come to visit our office, you would see this big golf ball in the sky. It might help you find our office. And it takes a picture of the atmosphere. It will look for particles in the sky. So what happens is it sends out a pulse, and now in the last 10 years it sends out both a vertical and a horizontal pulse, which kind of helps us see the shape of the particle in the cloud, whether it's a uniform circular shape like a raindrop, or if it's kind of different shaped like a hailstone, or if it's flatly shaped like a snowflake, etc. And so the radar will send out a pulse out to the atmosphere, and then most of the time the radar listens. It is waiting for the return signal to let it know what it sees, what rain and precipitation or snow it sees above the ground. We also do a weather balloon twice a day. Right now it's done at 4 a.m. and 4 p.m. That'll change with the time change next weekend, not this weekend, but the following weekend. It'll change to 3 a.m. and 3 p.m. But we're not the only office that does a weather balloon. There are 92 other sites across the United States that does it. And not just the United States, but worldwide. There are places all over the world doing balloons, and they do it at the exact same time we do our balloon. So it's based off of Greenwich Mean Time in England. And so everyone releases a balloon at midnight Greenwich Mean Time and noon Greenwich Mean Time, whatever time that is for your time zone. So while I'm releasing my balloon at 4 p.m., balloons are being released in Australia and in Japan and in South Africa and in Brazil and in Mexico. Like, they're being released all over the world. And all that data, the balloon is taking data. So there's the balloon here. This orange thing is a parachute. And then down here at the bottom is the instrument. And the instrument measures temperature, humidity, winds, pressure, and it sends data back into our computer system about once every 1 to 2 seconds. And it does that for about an hour and 45 minutes straight. And when that's done, we send that data out to a national center, and all that data from our balloon and all the balloons across the United States and all the balloons across the world gets ingested into the weather models that we use. The North American model, the Canadian model, the European model, any weather model used, all that data is shared from our balloons across the world. And our balloons can go pretty high. Planes fly between like 30 and 40,000 feet generally. And our balloon, this picture shows it, about 53,000 feet. But actually our balloon goes above 100 millibars. It goes to about 100,000 feet. It usually goes 10 millibars or higher. So it goes pretty high, and it takes about an hour and 45 minutes to do that. And then the balloon pops and the parachute hopefully expands and the instrument falls. We also have satellites that we use. We just, in the last couple years, got a new satellite on the west, and it provides 16 different channels. So there's water vapor that measures the water content high in the atmosphere. There's infrared, and that measures the cloud top temperatures. And then there's visible pictures that would be like if you were in space looking down at Earth during the day, what it would look like. So the cool thing about these new satellites is we get images more frequently, and there's lots more channels that we can have to use that can help in recognizing things like wildfires, thunderstorms. This little, it kind of shows an overshooting cloud top that kind of is a signature of a thunderstorm. We also use it to identify things like we can see burning, like if agencies are doing burn piles or doing prescribed burns, we can see that on the satellite. We can also use the different channels to, for example, if there's a lot of low clouds and fog, it can help with that as long as there aren't any mid and high level clouds. We can get a good picture of what valleys are seeing fog, which doesn't seem like a big deal during the day, but at night it's incredibly helpful because at night we don't have the visible to see. So we have to go off of the water vapor and the IR channels instead. We also have surface observing stations and webcams that we use. So the middle picture is a picture of an ASOS, that's an automated surface observing station, and that's located at several airports across our region: Spokane, Feltzfield, Pullman, Lewiston, Moses Lake, Ephrata, Wenatchee, Omak, Chelan, Methow Valley, Colville, Sandpoint, Bonners Ferry, Lewiston. I believe that's all of them. So there's a lot of them, and they automatically send us observations at least once an hour, more if conditions warrant an update. And it can measure temperature, dew point, winds, visibility, cloud cover and height, current weather conditions. It'll let you know if there's like a rapid rise or rapid decrease in pressure, wind speed, wind gust, wind direction. So we get that at least once an hour from these stations, and it's incredibly helpful. We also use webcams. We use a lot of DOT webcams, ski resort webcams, private people's webcams. If they're freely available online, we'll look at them. It's so incredibly helpful to see sometimes the sky. Sometimes it's incredibly helpful to see the ground so we can see if snow is accumulating. So those are some resources that we use on a daily basis. The image on the right would be different. Some of these are ASOSs, like Feltz and Geiger and Coeur d'Alene. But some of it is in Deer Park. I'm sorry, I left out Deer Park as a ASOS. But also we just have local people who set up weather stations that connect to our CWAP program, and we can get that data put on maps like this, and we can use it, and it's incredibly helpful. We also have high resolution models that we use. So massive supercomputers process this stuff rather quickly, and we can get, like the image on the right is something we call the href, and it's just a myriad of models, and it updates twice a day, and it can give us hourly forecasts of where they think the precipitation will occur, or we can see wind speeds or relative humidities and things like that. So it's incredibly helpful, especially in like the first 36 hours of our forecast period. And so we use that as well. So why do we need spotters? Well, we need spotters because if you look at this radar picture here, you can see this pink is Seattle's radar, and this kind of purpley blue is our radar. And you can see right here in the middle that there isn't very good radar coverage. And so part of the reason why we need spotters is to help fill in this radar hole right here, but also just to get real-time ground truth of what's going on. You know, sometimes the radar will overestimate things or underestimate things. And so it's incredibly helpful to get real-time information from people. And then, of course, to fill in our holes. Like it'll be snowing all day in the Cascades and the radar won't show anything because the radar sees in the Cascades from Spokane, it's like, I don't know, 10,000 feet above the ground. But in the wintertime, you know, snow tends to fall out of lower clouds, like clouds that are 5,000 feet or less. And so the radar completely doesn't even see anything below 10,000 feet. So that's why spotters are so helpful in kind of filling in the holes. Okay, so we have poll question number 1. I'm going to pull that out there for you. So, oh, well, I might have boo-booed that. Oh, well, you guys are answering, so that's fantastic. So what is the role of a weather spotter? Okay. I don't see any questions yet in the chat room, so I will close this and move on. So the choices were to provide ground truth, to add credibility to our watches and warnings, to fill in the holes, all of the above. So the answer is all of the above. Thank you for participating. I don't know if everyone saw that, so I will try and there's another poll question coming up, so we'll see if I can get that one to work better. If you guys didn't see it, I'm sorry. So what's in a spotter report? So we want you to kind of tell us the specifics, who, what, where, when, etc. So if you're not sure about your report, you can call and report your uncertainty, and that's totally okay as well. So there are different ways that you can report. The easiest way is to call our office with our spotter line, but you and to report, you would report what you witnessed, where you are, and the time of the event. And then if you needed to report, like for example, snowfall amounts or rain totals or hail size, you know, you would include that as well. But there are other ways to report your reports. So if you didn't want to call, you go to our webpage, and down at the bottom there's all these little links, and at the bottom is submit a storm report, and it would pull up something like this, and you would type in your report and it would send it to us and it would alarm on our computer stations that and we could see it. Unfortunately, I do not think we can acknowledge it, but it is a way to get it, and it does come through our computer systems in our office. Another very popular way is just to send a tweet or a Facebook post to us right now. So you could send it directly to us on Twitter at NWS Spokane. You can hashtag Washington or Idaho weather. You can share pictures or videos, or you can submit your reports on Facebook as well. Another option is Mping, and that is an app that you get on your phone, and it was created through the University of Oklahoma with NOAA and NASA, and it takes your position on your phone wherever you are, and you go on and you just hit select report type, and you only have so many choices. Like, you unfortunately you can't say certain things, or you can't type in, a comment. Unfortunately, that's the bad thing about it. But you can say raining, snowing, thunderstorm, winds with, minor tree damage or something like that. So you could submit it that way, and it pulls up into our computer systems, and we can literally zoom in and see where you are. And it's anonymous. We don't know who submits it, but it's incredibly easy to use. I use it a lot when I'm traveling. So like if I'm driving with someone, I'm not doing it while I'm driving, but while I'm with someone who is driving and like conditions are changing, I will submit maybe a couple of Mping. So if I'm driving up the South Hill of Spokane and it changes from rain to snow, I can Mping that it was rain at the bottom of the hill when I submitted, but by the time I got to 37th, it was snow. People have done it also on I-90. I've watched people literally on I-90 leaving Spokane and going towards Cheney, and they'll submit a couple of Mpings of the conditions as they're driving on I-90. It's incredibly helpful. I love it. I use it all the time at work. I always have Mping reports on my radar images at work. You can also email us at our account, nws.spokane@noaa.gov, and that website is, or that email account is monitored 24/7. And so you feel free to submit pictures or videos that way as well. So an example, let's do an example of a good report and a bad report. So on the left is Max Seazall, and he is Stevens 12 calling from his house in Colville. He's had heavy snow with about 3 inches on the ground. It began an hour ago. That's a good report. Thank you, Max. The report on the right needs some improvement. Hi, how you doing? Who is this? Well, hey, Greg, I'm a spotter in Ferry County. It's windy up here. The news says it's much worse to our south. Are you getting reports? How long is this going to last? So sometimes we can sit and talk with you guys, but sometimes as conditions are changing rapidly, or especially in the morning, when people wake up to snow and then they go outside and measure, and then they'll call and submit reports, we can get quite a few calls at one time. So we might not have a lot of time to sit and answer all your questions during those times. So for the most part, it's great if you could just state the facts, and we appreciate that. So as a spotter, we do get your information, and which includes your phone number, and just keep in mind we may contact you if we see something on the radar that we think we want to get some real ground truth about. We can call you and see what you see. So in the wintertime, that would be likely snow reports, or maybe flooding if we think you live near a creek or you're in a town that might be seeing flooding. So it's important to keep your emails current, because we do send out emails to our spotters. The two main reasons we would send out emails is if we expect a widespread severe event, where we would want you guys to kind of be on alert and available and ready to call us with reports or submit reports to us. And then the other reason being, we do send out a quarterly newsletter from our office about things that are happening in our area, and you might find that enjoyable to read. All right, poll question number 2. Let's see if I can do this. Okay. So what is the best way to provide What is, well, the question on this on the slide is different than the question in my poll thing. So the poll question is, what is the best way to provide a spotter request? And the answers, the choices are call the office, tell your neighbors or friends, social media post, send an email with pictures. Oh, what is not, I'm sorry, I was not clear. What is not the best way? What is not the best way? I'm sorry for the one person who was listening to me and didn't read. I was confused because the poll question was not the same as the poll question in the thing. I'll give you a couple more seconds while I look at questions. I still don't see any questions. Okay. So, yes, the best way to not provide a spotter request or report is to tell your friends and neighbors about it. Yes, I believe the email address is at the end of the slides, but it is nws.spokane at NOAA, NOAA.gov. Good question. All right, moving on. We're going to talk about cold season hazards across our region that we see. So the first is heavy snow. So we're interested in the first snow of the season, and then typically we're interested in any reports of at least 2 inches of new snow. And if you ever see 4 inches or more in 12 hours or less, we would appreciate a report. That's important as well. So what criteria must be met for a blizzard? So you need winds greater than 35 miles an hour, visibility a quarter mile or less, snow to be blowing around, and it has to last for at least 3 hours. So that would be the criteria for a blizzard warning. We also see wintry mixed precipitation across our area. The big one is freezing rain or freezing drizzle. The picture on the right and the picture on the left, if for those of you who've lived here for 20 plus years, those are pictures from Ice Storm, which occurred in November of 1996. But we also see sleet, rain to snow to rain or rain to snow. So we're interested in ice accumulation. Anything over a quarter of an inch would be an ice storm warning. But honestly, if it's precipitating and ice, if there's freezing rain or if there is sleet, we would want to know. So a call to our office or a report, one of the myriads of ways you can, would be fantastic. Because sometimes, like I said, the radar really overshoots a lot of the precipitation that falls out of the low to mid clouds. And so it's incredibly hard to see. So that would be so helpful. We also have strong or damaging winds a lot of times in the winter. These pictures are from windstorm of 2015. Some winds we saw last October, and then a windstorm we had in April of 2019. So any reports estimated over 40 miles an hour would be a good reason to call. Winds that produce any damage, like tree damage or power outages, And then severe winds are anything over 58 miles an hour. So if we expect winds to be 58 miles an hour or more, we would issue a high wind warning, or if it's convective in the summertime, it would be a severe thunderstorm warning. Good question, Mike. I will define sleet in a minute. Good question. So I know you're probably thinking, well, how do I know what the winds are, or how do I estimate wind speeds? You can use the Beaufort wind chart to estimate wind speeds, and that is included in one of the handouts. If you use your GoToWebinar, there's a handout section, and that is in there for you to use and download if you would like. Heavy rain we can see in the wintertime, like we're seeing right now, even though it's fall, we're seeing that occur in the Cascades today, and it'll shift tonight into tomorrow into North Idaho. So heavy downpours over long periods of time, a half an inch in an hour, an inch or more in 12 hours, or an inch and a half in 24 hours. Most of the wintertime precipitation we see is considered stratiform, so you would use this criteria. Convective would be like typically spring and summertime storms, thunderstorms and stuff. Flooding and ice jams. So we do see that a lot. We see rises on the rivers and streams in low-lying areas, and when conditions get cold enough, ice can start to accumulate and start to build up on the rivers. And then something typically happens that can cause the ice then to break up, and then you have these huge chunks of ice flowing down the river, and they can get all jammed up together. They can end up displaced quite far actually off the river because of the jam occurring. It's really amazing to see what water damage, what water and ice damage can do. You don't really think about it having that big of an impact, but people so underestimate the power of water and what it can do. And this was from a couple years ago when it flooded in Pullman one evening, and that was from just persistent heavy rain for a couple of hours. So that does occur in the wintertime across our area. We also see mud and debris flows. That's something we're kind of worried about right now near the burn scars, and a steep terrain with this heavy precipitation we're seeing in the Cascades and tomorrow in North Idaho. And we do see it when the ground gets saturated and then more rain falls on top, or when heavy rain falls on the burn scars and the ground is so torched that the precipitation can't move down into the soil. It doesn't get absorbed, and so it sloughs off the steep terrain, and that's how you get mudslides, rock slides, debris flows, and things. And we see it a lot in the fall, in the fall, and then again in the spring. In the winter, not too much, because in the winter it's kind of protected by the snowfall. All right, so poll question number 3. Okay, this is, again, a different question than what is on the screen. So here we go. What types of weather conditions could increase the threat of flooding? Ice jam, heavy rain on a burn scar, heavy snow, rapid snow melt. All right, I'm going to close that. Great job, you guys. So yeah, there's actually multiple answers for this. I would say the types of weather conditions um, that increase the threat of flooding would be ice jams, definitely increase the heavy rain on burn scars does. And in the spring, if you see rapid snowmelt, especially if it occurs like it's raining on top of the snow and it's warm enough that the snow is also melting, that does cause problems as well. So all three of those answers would have been fine. So thank you so much. Okay. So winter storm scenarios. So typically, a lot of times when we can see heavy snow, is what happens is there's cold air in place. Cold air sinks. So especially in the lower valleys, cold air in place, and then warm Pacific air rides over the cold air. And so that warm air carries a lot of moisture with it, and then it precipitates. And as it falls through that cold layer, the precipitation falls as snow. And then we also have the potential for freezing rain or sleet as well, and we'll talk about that. But that's a typical scenario that we see across our area. So the thing to know about winter precipitation is that the temperature profile is like so incredibly important in determining the type of winter precipitation we will see. So this is the orange or yellow here would be warm air, so that would be temperatures above 32 degrees. So if up here it's cold and it's snowing and it falls all the way into this warm layer, this warm layer is deep enough that the snow melts as rain, and as it hits the ground, it's rain. Now, there's another scenario where it starts as snow, it moves into the warm layer, it melts to rain, and then it's just got this little depth right here to fall through below freezing temperatures, but it doesn't have enough time to refreeze. But it's cold enough at the surface. So like your driveway is cold, your car is cold, the trees are cold, the power lines are cold. And so this rain, it's falling out of the warm layer, and there's not a deep enough cold layer before it hits the surface. And so the rain hits the ground and freezes on the surface. So that is freezing rain. Now, sleet, you have the snow falls into the warm layer, but it's not very deep. So it might melt a little bit, and then it moves back into a cold layer, and it refreezes before it hits the surface. And then you have snow where it is cold enough throughout the entire temperature profile, and so it all falls as snow. So here's a picture of some of the different winter precipitation types. So here on the left is sleet. So they're just tiny little, they're probably smaller than a pea, tiny little white little ice balls that kind of fall out of the sky. And then to compare it, you have grapple, which is what we see a lot in our spring storms. And grapple kind of looks like the stuff you stuff inside of a beanbag. And it typically is white, and it bounces a lot when it reaches the ground. And then you have hail, and hail is, this doesn't really show it very well, but a lot of times hail is clear, and it typically will not bounce when it reaches the ground. Grapple usually doesn't get too much bigger than pea-size hail, than pea size, but hail can get quite a bit bigger. Typically, we don't see anything much bigger than an inch here in our area. We have seen 3 to 3.5 inches here before in the past, but this is what you need to pay attention to for the winter is the sleet. Another big thing is atmospheric rivers. So that's just plumes of moisture that move into our region, and it provides wet and mild weather. So that would be kind of today. Atmospheric rivers are generally fairly long and narrow in their kind of shape. So you can kind of see here is a picture of an atmospheric river that would be moving into Oregon and potentially Washington as it moves on shore. So it's fairly common in the wintertime for us to see some kind of atmospheric river in our region. So some kinds of atmospheric river events, things that impacts we would see with that would be mud flows, debris flows, rock slides, flooding. All those kinds of things are things that we would see in an atmospheric river event. Hence, kind of like why we have our flood watches out for the Cascades tonight and for North Idaho. That's through tomorrow afternoon. We will see at times small scale low pressure systems that move across our region, and they typically develop behind a cold front. And they're incredibly difficult to forecast because they are so small in scale. They're not like a big cold front moving through or things like that. So they're really small scale. This is a picture of a meso low that went through, and you can see it's west of Spokane, and it dumped like a foot of snow in Reardon, but Davenport barely saw anything and Fairchild barely saw anything. So it's very small scale, but it can have a big impact on the area that it does impact. And this is another reason why spotters are so important, because we can get real-time data of, hey, it is dumping here right now, and then we can take action accordingly to your reports. So thunderstorms can happen, and they can occur in any season, even in the winter. So a severe thunderstorm would be winds greater than 58 miles an hour, or any kind of wind damage, and then hail greater than an inch, and then potentially a tornado. Although if there was a tornado, we would also issue a tornado warning. So less than 10% of thunderstorms in our area are severe, but lightning is always occurring in thunderstorms, and it is always a danger. And so unfortunately, the amount of lightning does not make a storm severe. So you can have rampant lightning and it wouldn't necessarily be a severe storm unless it had 1 inch hail and winds greater than 58 miles an hour. So why am I talking about thunderstorms? You're probably thinking, oh, it's a summertime thing, but we can see thunderstorms. You can see here on the graph on the left, we can see thunderstorms in November and in January in our area. So it's not out of the realm of possibilities. The image on the right is the time of day we typically see storms. And you can see the orange is winds, which we can typically see winds almost any time of day. And then severe hail typically occurs in the afternoon into the evening, and tornadoes as well, usually afternoon into the evening. So let's talk about some types of clouds that we see in the winter. So the bottom left is something I would say we see probably most often, and that is stratus clouds. And those clouds that usually out of stratus is what we see our rain and our snow in the wintertime. So they're just kind of low to mid clouds. It usually indicates stable conditions. You know, it will obscure the mountains. You know, sometimes we won't be able to see the mountains above us. We can also see scud clouds. So sometimes people mistake that for like maybe a funnel cloud, but that's just clouds kind of developing, moving through. It could be maybe a little bit of virga coming out of this cloud or something. We see cumulus all times of the year. Those are just clouds that kind of typically look like cotton balls. And they typically don't have any severe weather associated with them. We can see towering Q, and that's where we see our thunderstorms. And then we can see a wall cloud as well. So we can see that before a funnel cloud forms or tornado. And you can kind of see where a wall cloud would be, a scud cloud could be mistaken, vice versa. They kind of do look a little bit similar. So what about funnel clouds and dust devils? Well, funnel clouds stay aloft and attached to the storm, and they don't ever touch the ground. It isn't considered a tornado until the funnel cloud physically touches the ground, and then it is considered a tornado. Dust devils typically start at the ground and kind of push and move upward. And you can see, like in this picture here in the middle, a lot of times dust devils will form out of like completely clear skies. So you're not going to get a funnel cloud out of clear skies. You have to have a cloud moving through, because the funnel cloud has to move from the cloud and descend down towards the ground. So, if you see one of these and you wonder or question, you can always take pictures of any weather phenomena you see and email it to us, and we can respond with what we see in the picture. Okay, moving on to poll question number 4. So these questions are all different than what's on the slide, but identify this type of cloud or this type of precip, and I don't see a picture. Well, let's not answer that question because I don't see you guys seeing a picture. So I'm going to close that. I'm going to check for questions really quick, and then we'll move on. Okay. I don't see any questions, so we'll move on from that. All right, so let's talk a little bit about dust storms. Those are things we can see in late fall and spring. They typically happen after prolonged dry spells with strong winds and recently plowed fields. So we're kind of moving out of the dust storm time period, but like last year on November 7th, we did see dust. But we have had some pretty good rain, although I must say today and yesterday, I don't think parts of Grant County or Adams County or western Whitman County saw much precipitation. So they're still incredibly dry down there. And then most farmers have planted, I believe, their winter crops. But there's still the possibility for about another week or two to see blowing dust, and then that'll pick up again likely in the spring. So it causes a sudden reduction in visibility. It can close down roads and interstates. So if you see that kind of stuff occurring, please feel free to call us or reach out to us in one of the ways you can. Some dust storms are called haboobs, and they can travel actually very long distances. We haven't had a big haboob in quite a while, but several years ago, we had one that developed down towards the Tri-Cities, and it moved all the way up towards Colville. By the time it made it to Colville, it had kind of weakened a little bit, but while it moved from the Tri-Cities up through Spokane, it was quite strong. So we can see those here. And if they're widespread enough, or if they can cause air quality issues, albeit likely not a very long duration air quality issue. And then also something to keep in mind is smoke can limit our visibilities as well. But hopefully we're done with smoke for the year, and we won't see any of that again until next summer. So thunderstorms, lightning can strike as far as 10 miles from a thunderstorm. That's why it's incredibly important when you hear thunder to head indoors, because you don't have to be directly under the thunderstorm itself to necessarily be struck by lightning. So our big slogan is, when thunder roars, go indoors. So And more than 50% of lightning deaths occur after the storm has passed. So people think that they're in the clear and they go back outside. But like we said, lightning can strike miles away from the actual storm cloud itself. So just make sure you seek shelter inside a vehicle or inside a secure building, and to stay away from windows and doors. Don't use a corded phone or take a shower or bath either. So spotter safety, we love your spotter reports and we appreciate them beyond belief, but we want to make sure that you guys stay safe and you aren't putting yourself at risk in providing us reports. So, we want you to make sure you're not putting yourself at risk or in harm's way. So, if there's massive thunder and lightning, I wouldn't go outside to try and take a picture of it. If your entire deck is covered in a 1/4 inch of ice, I wouldn't want you out on your deck trying to walk around measuring the depth of the ice or something like that. Like we don't want you guys to get hurt in trying to provide us information. All right, let's see what poll question 5 is. It seems to always be. Let's be surprised. Okay. So you encounter a flooded roadway. What's the safest thing to do? Give you guys a couple more seconds to answer that. I like the last answer, but that's not the correct one. Okay. The best thing to do is to turn around and find another route. You do not want to drive through a flooded roadway because, like I said before, people so underestimate the power of water, and literally the road can be like eaten away by the water. The road might not even exist anymore. So if you're trying to go through it, there might not be a road to drive through. And we've actually seen that here. It happened a couple of springs ago. There was some really heavy rain in the spring. I believe it was in Adams County. And the road literally just disintegrated and fell into the creek and stream adjacent to it. So you definitely don't want to drive through flooded roads. All right. Mike, your question, it says that there are 16 people on tonight. All right. So moving on to terminology. So you'll hear us say a watch, a warning, an advisory. So what do those mean? A watch means basically get ready. Weather is what we're forecasting is favorable, but not necessarily imminent. A warning means that we are confident or the weather is occurring, so act now. An advisory would be a minor nuisance or inconvenience. And actually, the Weather Service is looking at removing advisories and just doing watches and warnings. So the types of warnings that we issue tornado warnings, severe thunderstorm warnings, flood, snow, ice, cold, like extreme cold, wind, fire weather, freeze warnings. These are all the types of warnings that we issue. And some ways to receive our watches and warnings, one way would be through NOAA Weather Radio. And you can see the areas in white on these maps is where you can receive reception for NOAA Weather Radio. So a lot of the mountainous regions, it's a little bit more difficult to receive NOAA Weather Radio. But it's a great way because NOAA Weather Radio is on 24/7. You can turn it on anytime you want, get a forecast, turn it off, you're good to go. You can get severe warnings and any kind of products we issue that is put out on NOAA Weather Radio, and they can be alarmed, like a severe thunderstorm warning can be alarmed so that you would be notified. Another way to stay informed is just through our website, and lots of good information on there. So just kind of play around with our website. And if you have trouble finding something you're looking for, you are always welcome to email us and ask us questions about where can I find this or where can I find that? And we would be happy to answer that for you. Another way is through, we aren't allowed to have an app, but we've created mobile.weather.gov, and that you can bookmark and it behaves like an app. I have it on my phone. It's incredibly helpful. You can set it up for multiple cities. This is like a national slide, but you can set up for multiple cities. So I have it set up for my house. I have it set up for my stepson in Pullman. I have it set up for my brother on the west side. I have it set up for my parents who winter in Arizona. So I can kind of click on and see the weather for those locations as well. So it is very helpful. It has, you can get observations, you can get the forecast, you can read our area forecast discussion, you can read any kind of watches or warnings or advisories we have out. So it's very helpful to use. We also do WEA, it's Wireless Emergency Alert. And what that is if we were to issue something like a snow squall warning, for example, which is a winter product we would issue. If we were to issue something like that, if you were driving through the area that we put out the snow squall warning for, your phone would automatically go off. It also works for tornado warnings, flash flood warnings, extreme wind warnings, dust storm warnings also. And it is incredibly helpful. But we also works for things like presidential and national declarations and emergencies as well. And it's a setting on your phone. And if you wonder if your phone is set for it or not, your phone automatically is set for it when you get your phone. You would have to physically go into your settings and turn it off if you did not want those alerts. Okay. Well, Marvin, maybe you can email our office and we can look at helping you with the mobile.weather.gov, because mine works. And I don't have problems with mine. I have a Droid. And then okay, Dan, I don't know if the slides are going to be available, but the actual presentation will be put online. I can ask Robin about the slides. I think she put the slides out from last spring online. So I would guess that the slides from these would be available as well. Maybe not until after the second spotter talk is done in a couple of weeks. These are great questions, you guys. Thanks. Another way to stay informed is through the FEMA app. That will give you weather alerts as well. On your phone if you're interested. Oh, there's another question. Hold on. Oh, very good. They say mobile.weather.gov works on iOS too, so that's good. So just ways to be prepared for disasters, to have an emergency kit for your house, and an easy way to grab and go if necessary. I know a lot of areas nowadays actually need to be prepared to evacuate in case of a fire. So these are all important things just to have quickly with you. But in the wintertime, our biggest threat probably would be a power outage, a potentially prolonged power outage. So having water and food and medication, flashlights, food that you can eat without power, a whistle to blow for help, and other things like that are incredibly helpful to have. I know I have a emergency kit in my closet, and actually in it I have a book bag as well, like my old school book bag from high school. And so if I need to, I can just shove stuff in the book bag and get in my car and go. I also have a list on the side of my refrigerator. So if I had to leave quickly, when you have to leave quickly, you're not thinking straight. You're like, oh my gosh, what do I do? What do I grab? Oh my goodness. I literally just have a list of like the top 5 things. So if I were to have to evacuate, I can go to my list, see my list and be like, oh yeah, I need to grab my cat. Oh yeah, I need to grab this bin of photo albums. Oh yeah, I need to grab my grab and go bin of emergency supplies. And I can quickly put those things in my car and go in a matter of minutes. All right, so there's other ways to be involved other than a weather spotter. So we're going to talk about those really quick. You're here because you're going to be a spotter, but there's other ways too. If you really want to get involved, there's other things. And one of them is CocoRa's. And Robin will be doing some CocoRa's talks. So you're welcome to join those. I think the first one is next week. And you can check our website or Twitter with the dates and stuff on that. But you are welcome to join that as well. And that was developed in the late 90s after some flash flooding occurred in, I believe it was Fort Collins, Colorado. And so this is just reporting rain and snow amounts once a day. So you purchase a rain gauge, you create an account, and you submit daily. Now, you don't have to submit daily. If you don't submit one day, but you submit another, that's better than nothing. So it's just 24-hour total precipitation or snowfall amounts. And we get them every day in our computer system, and they are incredibly helpful, especially in the wintertime, to get snowfall reports of how much snow you've received. So there is a CocoRa's website, you can see here, and it updates, it shows you every day precipitation amounts from the CocoRa's observers that have submitted. It's very easy to do, and Robin's going to give a class on that, and so she'll answer any questions you have about CocoRa's. But really all you need is just a rain gauge and a ruler to measure your snow. So pretty simple. There's also the CWAP program. So that's for if you have a local weather station at your house. You can log in and create an account with the CWAPs. And that is kind of the information that would show up like on our maps in our office of other local things. And that would be temperature, it could be winds, it could be precipitation amount. It's all incredibly helpful. This is the CWAP website. You just literally go into Google and type CWAP and this will pull up. And so this is the website. It is a little bit kind of clunky, but this is how you would set up your observing station to get put into the CWAP program. So these are just kind of the different ways. Again, yeah, the CWAP's a daily commitment, but really you just got to make sure that your weather station is operating. It's incredibly simple. CocoRa's is a daily commitment. And then Spotter is a spotter basically is event driven. So when needed, when things occur, then you would call or let us know what's going on. So So there are weather resources online. I believe that's on the right-hand side under local programs of our webpage. And you can see Robin did put the notes, so I'm guessing that's the slides. So you will be able to likely see the slides from today's, but she probably won't post it until after the second spotter talk in a couple of weeks. I think we have another question. Oh, it's on Tuesday night. Thank you. Yeah, the next spotter talk is, or the Coco Roz is on Tuesday night. Thank you. All right, let's see what poll question number 6 is. Let's see. It is, what is a great way to stay informed about hazardous weather? All right. So I'm going to close that. Yes, your answer is correct. All of the above. So on the internet is a great way to stay informed. Cell phones with weather apps and even radar apps are incredibly helpful. And local TV stations giving you the latest and greatest. And, you know, we do have a chat room that we have set up with the local media. And so they are always welcome to get in the chat room with us and ask questions, ask for updates, etc. And we do communicate with them on a fairly regular basis. All right. So moving on to our winter outlook. We're getting towards the end here, which is great. I think we'll end on time. So our winter outlook. Oops, sorry. Let's go back. Let's go back. There we go. So what happened so far this fall? Well, we've had above average temperatures and our precipitation has been a little bit on the dry side, but this map is from a couple weeks ago, I would guess. So it hasn't updated probably with all the precip we've received in like the last week or two. So that might be a little bit different for the precipitation. We might actually be a little bit better, near 100% of normal for our average, for our 30-year average. So we did have a record hot, dry summer this year, and the warm temperatures have continued into the fall, and we have been fairly dry, but thankfully in the last couple of weeks we have seen some wet systems move through. So things are looking up. What about our drought? Well, this was the drought monitor that was sent out today. And, well, I don't think that was the one from today. I'm sorry. The one from today actually takes exceptional drought, which is this dark maroony brown, and it takes it into southern Spokane County. So that's good. We are improving. I think it took it out of parts of Lincoln County as well. But this exceptional drought across like Lewis and Nez Perce counties, Benoit, Latah, Whitman, Adams, continues. It is still exceptionally dry across these regions. And actually, I was looking in the last couple of days, and some of those areas need anywhere from like 10 to 20 inches of rain over the next 5 months for the drought to quote unquote end. So looking at the outlook, you can see that it's calling for the drought to remain through the winter, but that conditions will probably improve. So we're moving into winter, we're moving into our wetter months. So, you know, and considering we're moving into a La Nina, we are hoping that we will see improvements to the drought conditions as we continue through winter. So our La Nina status. This Climate Prediction Center has issued a La Nina advisory. The temperatures in the equatorial Pacific have cooled, especially in the last month. So that's this image on the left. You can see all this blue across the equatorial region. It is still kind of warm right off the coast of South America, but the rest of the area is very cool. And this image on the right kind of shows you the depth of the cold. And you can see the cold waters go pretty deep across the equatorial region. So we are in a La Nina advisory, and La Nina is expected with an 87% chance across the northern hemisphere for this winter. So this is our typical La Nina pattern. So typically the jet is kind of pushed to the north of us a little bit, with the colder air to our north and east, and we will see usually some wetter systems move across our region. So the climatology for La Nina winters is we typically see above average snowfall for our region during La Nina winters. So you can see the only places that really don't is up here in northern Stevens County and then down here in parts of Douglas County. But that's pretty close to near average. But most other places see anywhere from 110 to 130% of average, 140 around Lewiston and Clarkston, 100% of average of snowfall during a La Nina winter. So Spokane La Nina winters. So average for La Nina winters is about 48 inches for Spokane, but you can see it does vary. There are so many months that are well above average, and then there are years that it is well below average. So it is a mix. But what we're seeing our second consecutive La Nina. So what does that look like? Well, again, it's kind of a mixed bag. So here's the normal range, or these dotted lines. And you can see consecutive winters in the 50s through mid 80s were typically near normal or above normal. But you can see as we've moved into the late 90s through now, it's kind of a mixed bag where you'll see near normal or below normal or above normal for the second consecutive La Nina winter. So looking at some analog years of consecutive La Ninas. So this is looking at the second La Nina winter when it's in a row. So in those years where the second La Nina occurred, what happened? Well, on the left-hand side is temperature, and so you can see typically the temperatures have been at or below average for the winter months. The precipitation, though, has been drier, okay? But looking at our outlooks, back to the 1 month, looking at our outlooks for November, you can see we're saying equal chances of temperatures on the left, but we're seeing a signature for above average precipitation for November across our region. Now, as we take that through the winter, December through February, you'll see that the Climate Prediction Center is saying below average temperatures and above average precipitation. So they're going with the typical La Nina winter that we could see across our region. So the key points is that the drought will likely continue, but we can see some slow improvements after our hot and dry summer. The La Nina advisory we have a La Nina advisory for the upcoming winter for La Nina conditions with slightly elevated odds of cooler and wetter than normal. And then, winter is coming, so anticipate periods of snow, potential ice, rain, and wind. So thank you guys so much for joining. There's our email address again, if you want to write that down. And I will unmute you guys. And if you would have to unmute yourselves as well. And if you have questions, you're welcome to ask them if you would like to ask questions. Or you can just post them in the room as well. Well, thanks, Mike, for joining. I hope you enjoyed. Does anyone have any questions? I'm not. Oh. Dan has a question. I'm hitting unmute. You have to unmute yourself. Of course, last time I tried to do that, it didn't work. But I hope you can. You're welcome to talk if you can. I'm getting a question that says, where do we find the downloads mentioned? So if you still have your GoToWebinar up, there are handouts. There's a handout section. There are handouts on that. And you can click on those. They're just PDFs. And you can download them, I believe. If we are a current spotter, where do we register for attendance? I believe, Marvin, that you signed up, and so Robin knows about it, and so she's aware of your attendance. Define a trace of precipitation. Good question, Mike. So a trace of precipitation would be anything less than 100th. So it could be just a few spits on the ground that barely wets the ground, up to just less than 100th. The meniscus has to be at 100th for it to be 100th. So if it's just under 100th, it's considered a trace. I'm gonna have to get some training, I guess, on how to unmute you guys, because I have here that I've unmuted you. Attendees will have full audio control. I may unmute. Yes, unmute everyone. Oh, I hear someone.
This is Frank Hutchinson. You can unmute yourself if you click in the upper right-hand corner. That's where it is, the microphone. If it's red,
yes,
you just click on it and shoot in green, and you can talk.
Awesome.
That worked for me too.
So yes, I would say a few drops of precip does qualify as a trace because it fell out of the ground and it hit the ground. So that would be a trace of precipitation. Does anyone else have any other questions? Thanks for joining, Rebecca.
Can you hear me?
I can.
Hi, this is Lisa.
Hi, Lisa.
You mentioned the other classes of information. Is that part of the email?
I don't.
Do you have the information of
I don't
the
know
additional classes in an email?
Yeah, I don't know what Robin sent you, but I'm loading up our webpage, and
Okay.
On our webpage it has the spotter training information, so you can see spotter training was tonight and November 9th, and the Coco Ross training is November 2nd and November 18th. Is that
Okay,
what you were looking for?
Yes.
Yeah.
Yep.
And then I think you can sign up for it. I think they included Yeah, there's a website here at the bottom to register. And there, we had a test avalanche product today, so I don't know if it was put back up. Yeah, fall at the top of the page, you can there's just a direct link right there that you can register at the top of the page as well.
Okay, thank you.
Yeah.